Welcome back. Pre-calc, we are working on trigonometry. And you probably remember this phrase from geometry, SOHCAHTOA. In trigonometry, that's the sine, cosine, and tangent. That's what the S, C, and T stand for from geometry. And what we have is in a right triangle, the angle across from the right angle is always called the hypotenuse. That's what the H stands for in SOHCAHTOA. And then depending on what angle we're talking about, whether it's A or B, well, depending on where theta is, I guess I should clarify because you may not have seen that before. This is a Greek letter. It's spelled theta. It's pronounced the way I just said it. And what we're talking about is theta is the angle that is made, that's the non-right angle. So if I called it right here, then the opposite side would be across from that. And then adjacent is the side that's next to, that's what adjacent means, next to, that's not the hypotenuse. So that's what the O stands for, opposite. H is the hypotenuse again. A is adjacent. H is hypotenuse. O is opposite. A is adjacent. And again, sine, cosine, and tangent in SOHCAHTOA. So as we look at this problem, notice though that instead of saying theta, they're talking about angle A. So I really do need to erase, the things I have written here. Now the hypotenuse never changes. That's kind of nice. But if we were looking at the ratio of A, well, you look at where angle A is. I guess I should clarify. We always do the trig function of an angle, by the way. And it's not a right angle, not until, down the road. So anyway, if we do sine of A, the opposite side, because remember sine is opposite over hypotenuse, is side length BC over the hypotenuse, which is side length AB. So what you probably have never seen before is this one. This one is what is called cosecant. Okay, this is the reciprocal of sine. I always remember because the S goes with C. I don't know who came up with that, but that's how I remember. So what that means is if sine is BC over AB, then cosecant is going to be AB over BC. So just changing colors to do this. And remember, cosine is adjacent over hypotenuse, so adjacent to angle A is side length AC over the hypotenuse is still AB. That's not going to change. By the way, you'll notice I go in alphabetical order, it's just out of habit. So if CSC stands for cosecant, SEC stands for secant. Just to give you a heads up. And I remember that it's the reciprocal of cosine because C goes with S. S goes with C, C goes with S. So what do I mean by the reciprocal is we flip that. AB over AC is that. So then looking at tangent, again following SOHCAHTOA, tangent's opposite over adjacent. Well, opposite of angle A is side length BC, and then adjacent is AC, and this is cotangent, in case you've never seen this before. Cotangent, that's how you spell it, C-O-T, because we're lazy in math, we write the shorthand, is the reciprocal of tangent, AC over BC. So as we move forward to the next one, and I'm color coding this for a reason, is if we look at angle B and I ask you for sine of B, well, opposite of B is sine length AC. So opposite over hypotenuse is AC over AB. Notice that I'm trying to get you to notice the colors there, and then cosecant would then be the reciprocal of that. So AC over AB. Switching colors for cosine. By the way, you can pause this at any point and you can try to fill this out the rest. especially if you remember SOHCAHTOA from geometry. Well, cosine is adjacent over hypotenuse. Adjacent to angle B is BC. The hypotenuse is still AB. So do the reciprocal. AB over BC. And notice my color coding here. And then tangent, let's say I used orange. Tangent of B, well, opposite is AC. And adjacent is BC. And then cotangent is the reciprocal of that. And what you're supposed to notice about this is the reason why we call sine and cosine, secant and cosecant, tangent and cotangent, is this little phrase right here, and I'll change colors again, is angle A and angle B are complementary angles. And if you forgot what it means to be complementary, here's your definition. It's two angles that add to be 90 degrees. That the sine of A, and if you look at the cosine of B, maybe I should have color-coded this, but they both equal the same ratio, BC over AB. BC over AB. So what can we deduce about the two of those things? They are equal to each other. And that's where we get this phrase of sine and cosine, because they are complements of each other. So, like hypothetically, now I'm not trying to, and maybe I should just tell you to go to a calculator and say, what if you did sine of 30 degrees? If you type that into your calculator. Well, let's do that. And maybe I should point out that make sure you're in the right mode. So I clicked on the mode, go down, and down a few times to change it to degree mode. Hit enter on degree. Second mode gets you out of that. If you hit sine of 30 degrees, you get an exact number, 0.5. Well, that means if you do cosine of the complement of 30, well, what's the complement of 30? What's the number that adds to 30 to give you 90? 60. Hit enter. You get the same exact value. That always happens. And you try with any number you want. Sine of 1 degree, you'll get an ugly number. Well, that means that cosine of 89 is that same ugly number. That always works. And you can do that with secant, and by the way, I can switch these around. Secant of A is equal to cosecant of B, and then tangent of A will equal cotangent of B. And I can switch these around, like sine of B equals cosine of A. Secant of B equals cosecant of A. All of that is true. And not a lot of teachers actually teach that. It's kind of surprising, actually, but pretty important stuff there as we move forward. The next thing you probably remember, and if you don't remember, it is actually a formula that they give you on the SAT. And the whole premise of this is if we have a right angle with one angle is 45 degrees, well, since the three angles have to add up to be 180 degrees, this angle also has to be 45 degrees. How about this? Instead of teaching you kind of like the way this is asking you to, I'm just going to give you a problem that makes perfect sense. Okay, so if it's a right angle, and these two angles are exactly the same, that's the only way to add up to be 180 degrees, and one of them is 45, the other one has to be 45. Then these are base angles that are congruent. Well, what do we know about base angles that are congruent? That means that their legs must also be congruent. So let's say I called this side length x. Okay. Well, what that means is that this side length must also be x. And then we could do the Pythagorean theorem. If you forgot the Pythagorean theorem, that would be x squared plus x squared, a squared plus b squared equals c squared. The only thing is the two legs are identical. So x squared plus x squared must equal, I'll just call this c for the Pythagorean theorem. So what we have is 2x squareds is equal to c squared. And then from there you could say, well, what does c equal? Well, let's square root both sides. Kind of want to change colors. So c must be equal to, well, I don't know the square root of 2, but I do know that the square root of x squared is just x. So this side length is always x root 2. So let's say in this problem we had, I don't know, since it says BC equals 5, that means that this is 5, and AC also has to be 5. You know, that's kind of what we're getting at here. And then if you do the Pythagorean theorem, then this side length has to be 5 root 2. Yeah, and we could do this all day. So how do I want to phrase this? Is if you know the leg, well then the hypotenuse is equal to the leg times root 2. That's my cursive L, by the way. And what if you know the hypotenuse and you want to work backwards? Well, how do you go backwards from multiplication? You divide by root 2. Now, most people would rationalize that, and they would write it's the hypotenuse root 2 over 2. And if you're confused by that, well, we can talk about that at any point. And maybe I'll conclude this video with kind of winging this last thing as well. I think I want to move my screen over. Sorry if that bugs you. And this is an ugly drawn picture. This is not a very nice visual. So maybe what I'll do is I'll just create my own. There we go. I'm just going to make my own problem. Sorry, it's not following. But let's say that this side length is 30. Or sorry, angle. That was a terrible. An angle is 30 degrees. And this is a right angle. Well, again, the three angles have to add up to be 180. So this angle must be 60 degrees. That's where we get the phrase 30, 60, 90. Again, most of you probably remember this, but it's worth repeating. So let's say you knew this. Well, I guess I should compare these first. And why do we call them what we do? First of all, the angles definitely go in order, 30, 60, 90. 30 is the smallest. And if you remember in geometry, across from the smallest angle is the smallest side. Well, in this case, we're going to call that the short leg. And remember, across from the right angle is always the hypotenuse. So there's nothing to think about there. And across from that middle one, well, between the two legs, I guess I should remind you that the legs are on both sides of the right angle. So this is the leg and this is the leg. Well, between the two legs, across from the 60 is the longer leg. All right. Now the reason why I'm writing it very far away is because I'm going to add that same exact triangle on this side. The reason why I'm adding the same exact triangle is now what I've just provided for you, if you look at the giant triangle, is an equilateral triangle. Well, what does that mean? Okay, well, let's say we knew the short leg was x. Well, that means over here must also be x. So what's the total length of the side? 2x. Now remember, all three of these angles are 60 degrees. So this must be an equilateral triangle, which means the hypotenuse must be 2x as well. Now why do we do that? Well, the long leg here in the middle, we can now do the Pythagorean theorem to figure out what that long leg would be. The Pythagorean theorem would be x squared plus b squared is equal to the quantity of 2x squared. So as you're looking at that, x squared plus b squared is equal to 4x squared. Got to square each piece. Subtract 1x squared over. Well, 4 minus 1. Okay, well that's 3x squareds. And if I ask you to solve for b, you got to square root both sides. Well, I can't square root 3, but I do know that the square root of x squared is x. So what am I saying is if you know the short leg and you want to figure out the long leg, you take the short leg times root 3. Let me write this as x. And if you know the short leg and you want to figure out the hypotenuse, you have to double it. Now we can work through this any way that we want. And again, hopefully this was a reminder from geometry and you're not learning this for the first time. So I'm at the end of my time. I'm going to see you in the next video to continue these notes.